All right, this one is function operations, and what we're going to do is just combine the given functions that are listed up here as directed here below. It says find and simplify g of x plus h of x. So we're literally going to take the g of x function, which is 2x plus 8. So we're just taking the right side of it, and then we're going to add that to the function h, which is negative 6x squared. So instead of writing a plus, I'm going to write the negative 6x squared. And then minus 32x and minus 32. Now, that actually is the two functions added together, the sum of the two functions. However, we can do some simplifying, and we can put the expressions, the terms, in descending order, like which is the typical way of doing it, and it's also directed up here. So I want to make sure to follow that. So I'm going to combine like terms. So let's start with this 2x and this 32x, negative 32x rather. So if I combine 2x's and then take away 32x's, then I'll have negative 30x's. So I'm going to erase those and put that right on the other side of my x squared term, so negative 30x. And then I'm going to combine this positive 8 and this negative 32. So if I add 8 ones with negative 32 ones, or if I start with 8 and I take away 32, I'm going to be left with a negative amount, which if you subtract 32 minus 8, what would that be? 24, I believe. And then since the bigger number is negative, we're going to make that a negative. So we'll get rid of the others. And I did that in my head, and luckily I was right. Okay, so that's that first one. The second one here, we're going to combine h of x and g of x, but we're going to be subtracting them. And we're going to start with the h of x function, so I'm going to write it here first. Negative 6x squared, then negative 32x, then negative 32. Okay, then I'm going to subtract, right? But when I subtract, I have to be more careful than when I do addition, because these polynomials have multiple terms, and the negative or the minus is going to be, we need to apply that to all the terms. So looking at g of x, which has two terms, I want to be careful that I either put it into parentheses first and then distribute the negative. So you kind of think of this as like a negative 1 getting multiplied to both the 2x and the positive 8. Or if you wanted to do a shortcut, you could have just noticed that since we're subtracting the second function, we want to make sure to change the signs on all the terms in that g of x function. So instead of writing a positive 2x, I would make sure it's minus 2x. And instead of writing positive 8, I'm going to write minus 8. Okay, so that's another way of looking at it to achieve the same result. Next, I'm going to combine like terms, and I didn't say this before, but remember what we mean by like terms is terms that have the same variables with the same exponents. So this negative 32x, the x has a power of 1 on it, and then I have this negative 2x over here. So that's a like, those are like terms because they both have the x to the first power. And so we can combine those together just like if we had 32 oranges and 2 more oranges, we would have a total of 34 oranges. I can combine 32 x's with 2 x's. And in this case, they're both negative. So it'll actually be a negative sum. So negative 32 minus 2 more would be negative 34 x's. So I'm going to just change this to a 4 here and get rid of that other x term. Okay, then I can combine the like terms here. Here are these two. The negative 32 is a constant and the negative 8 is a constant. So those are like terms. Using the definition that I said before, terms that have the same variables with the same exponents. So you don't see variables here, but you could force it. You could say that this is negative 2 times x to the power of 0, because when we do the power of 0 on anything, we actually get 1. And so negative 32 ones is the same thing as negative 32 times x to the power of 0. And likewise, this would be negative 8 times x to the power of 0. But we typically do not write x to the power of 0 because it would just simplify down to 1, and we like to have everything simplified. So we're just going to write those as constants. And combining those two together, I get negative 40. And then I just want to make sure that the expression is written with all the terms in descending order by their powers. So x to the power of 2, then x to the power of 1, then x to the power of 0 is what we mean by descending order of powers. So now I'm going to submit that. Yay. Okay, next one. Find and simplify f of x times h of x. So now I'm going to multiply the first function f of x, which is just 9x, times h of x. And h of x, h of x has 3 terms in it. So I am going to first write this so that the h of x is in a set of parentheses. That way I can make sure I remember to distribute the multiplication of negative 9x to every single term in the second function. Okay. Right, now I'm going to simplify it by multiplying 9x, starting with, I'm just going to write it over here, 9x times negative 6x squared is going to give me, well, first I'll do 9 times negative 6, which is negative 54. Then x times x squared is going to give me x to the power of 3. Okay, so I've already taken care of that first part. Right? Now I'm going to do 9x times negative 32x. So positive 9 times a negative 32 is going to give me what? Negative, what's 9 times 32? Well, 9 times 30 would be 270, and 9 times 2 would be 18. So if I add 270 plus 18, I would get 298. Pretty sure, 298 x's. Then, actually it's x times x, so it's x squared. Now, I've taken care of that second term. Now 9x times negative 32 is 9 times negative 32 negative. 9 times 30 is 270. 9 times 2 is 18. So again, well, I don't know why I'm doing that again. I already did the same thing before. So it's negative 298. All right. And x to the power of 1. All right, so there I've taken care of the rest of that. I'm just going to get rid of all this. Oh my goodness, I made a mistake somehow. All right, let's track back through the work. So 9 times negative 6 is negative 54. Maybe I messed up in my multiplication of 9 times 32. 9 times 30 is 270. Oh, it's 288. Silly. Let me see. Let me see if I just change this. Yeah, I don't know why. I said 298 is 288 when I multiply, or when I add 270 plus 18, it's 288, not 298. Okay? All right, now I have h of x divided by g of x. And it says, hint, you will need to factor h of x. Okay, so let's start by factoring h of x. And maybe we want to do this, I guess I'll write this one out. Hold on one sec. Well, I thought I paused and I didn't, so okay, cool. We're here now. We can go ahead and multiply this. I'm sorry, not multiply, but factor this. So we're going to factor this h of x polynomial here. Okay. So I have negative 6x squared minus 32x minus 32. The first thing I notice is that I can factor out a negative because all three of these terms have a negative. So I could factor out a negative 1 times positive 6x squared plus 32x plus 32, but that's not all. I also see that all of these numbers are even, so instead of taking out a negative 1, I could have taken out a negative 2, and that would leave me with 3x squared plus, what's that, 16x plus 16. And I think that's as far as we can go because 3 is prime and 16 is even, but so you could do 2 times 8 and even 2 times, or really 2 to the power of 4. But, sorry, I wrote that terribly. But I don't have any common factors other than 1 with that first coefficient of 3. So I'm not going to be able to take out any other common factors. So the greatest common factor is negative 2, and I've already taken that out. Okay. I'm just going to write an equal sign here to show that these are all equivalent. All right, and then the next step I'm going to do, I'm going to see if I can take this quadratic polynomial and factor it into 2 binomials. So being that 3 is prime, I know I could have 3x and x. I'm definitely going to have 3x in one set of parentheses and x in the second set of parentheses. Next, I'll choose the signs for my 2 binomials. Seeing that I have a positive on the end here, my third term, that means that the 2 signs in my binomials are going to have to be the same, either 2 positives or 2 negatives, in order to multiply and get that positive coefficient on the end, or positive constant on the end. So to know whether it's going to be 2 pluses or 2 minuses, now I will look at the middle term sign, and being that it's plus, I know that I have 2 pluses. Okay. All right, now I'm ready to start thinking about what numbers are going to go in the last place in each binomial. So I'm now going to do 3 times 16 because, well, actually, this might be a little hard for some of us. So we're not going to be able to come up with, well, there's a few different ways. Okay, there's the scissors method, which I believe is where you do like 3 times 16 and then you come up with the factors of 3, for instance, and the factors of 16, which are 4 times 4, or like I said before, 2 to the power of 4. You can keep breaking those 4s down. And then you try to find a combination that's going to give you, I don't think I'm even explaining this right. To be honest, guys, I'm gonna just cancel this. I don't use the scissors method, but you can look it up if you want to try to see if that might be helpful to you, but I don't teach it that way, so I don't know why I'm trying to show that. What I usually do is teach the AC method, and the AC method is where you think of the coefficient of the x squared term as a, the coefficient of the x term as your b, and the constant is c. And then you multiply a times c, which in this case will give us 30 plus 18, so 48. And you're looking for two numbers that will multiply to give you 48. So two factors of 48, and those two factors of 48 need to add up to a sum of the middle term, which in this case is 16. And I already know that they're going to be two positives, so I don't need to worry about the signs. So I can start with anything. In most cases, it's going to be the two numbers that multiply together to give you that AC value that are closest to each other, but not necessarily all the time. And I like to start with like 1 times the number, then I'll go to 2 if it's even, 2 times 24, and then 3 divides in there, we know, because we just multiplied 3 times 16, so 3 times 16. 4 will go in, 4 times 12, and there I found the combination that's going to give me 16 when I add them together, right? So I was just going through, and I could have been showing like 1 times 48 would give me 48, but when I add them I get 49, so that's not what I'm looking for. 2 times 24 gives me 48, but when I add them I get 26, and I'm looking for 16, right? And so I'm just going through. 3 times 16 gives me 48, but when I add them that's 19, so that's not the winning combination. And then 4 times 12 gave me 48, and then added to give me 16, so that's the winning combination. But those two numbers do not just go right up in here. I have another step I have to do. So what I'm going to do is I'm going to back up to where I had, I'm going to move, I'm going to make space, grab these, oops, not that, these things, and I'm going to move them down, and I'm going to have another step right here. So that I have -2, and then I'm just going to write some big square brackets here. And then I'm going to write the 3x squared, and then the positive 16. And what goes in the middle is going to be using those two factors that I came up with from before. So I'm trying to scroll, but I can't scroll. Don't know why. Let me see. The old-fashioned way here. Something is cut off. I don't know why it's cut off. I guess I need to extend now. There we go. Now I'm going to take that 4 and that 12, and I'm going to put those up here. 4 as a positive 4x and a positive 12x. So then I've got my 4 terms, which I can now group into 2 sets and factor out the common factor. So now I'm going to have -2, and I'm going to factor out of the first pairing an x, so that I get x times 3x plus 4. And out of the second pairing, I'm going to factor out 4, so that I have 3x plus 4. And then notice I get those matching sets of parentheses there. And I can factor that out. So I guess I needed even more space here. I'll do this again. Okay, so in the next step, again, I'm just going to rewrite -2, and my big squares, square brackets. Now I'm going to take this common factor of 3x plus 4 here and factor that out. And that's going to leave 9x plus 4 to be in a separate set of parentheses. And then actually at this point, I don't really need these square brackets anymore. And so then as you can see, that's what was supposed to go. Now we can see the numbers that were supposed to go in these boxes here. Okay, so now that I've got that factored, that was my top function. Because remember, the whole reason we were factoring this out is so that we could find h of x divided by g of x. And we were told to factor, I think, because something's going to cancel. Some of the factors are going to cancel. So I need a little bit more room. Let's see. Why is this giving me trouble? There we go. Okay, so now I'm going to take the h of x that we just figured out here in factored form. So h of x is negative 2 times 3x plus 4 and times x plus 4. And then I'm going to divide all that by g of x. And g of x is 2x plus 8, but I can factor out a 2 from each of those terms since they're both even. So I get 2 times x plus 4. So notice that this x plus 4 and this x plus 4, if we divided them just by themselves, that would give us 1. Because any number divided by its own self is going to give you 1. So like 3 divided by 3 would equal 1. Negative 2 divided by negative 2 would equal 1. The same thing as if we have an algebraic expression that's the same on the top and bottom. So there, those cancel out to 1. Also, we have the negative 2 and the positive 2 are going to cancel out to negative 1. So now I'm going to rewrite this. The only thing that's going to be left is a negative 1 times this quantity 3x plus 4. So negative 1 times 3x plus 4. And then to simplify that, I'm going to distribute negative 1 times 3x and negative 1 times positive 4. And so that will effectively just change each of those terms' signs. So I end up with negative 3x minus 4. Okay, we can go over and put that in. Right, and finally, it says give the domain restriction for f of x. In other words, what values of x cannot be used in this function g of x over f of x? Well, let's find the function first, and then we'll look and see what values would not be usable there. Well, actually, since we're not asked to find the function, we can just focus in on f of x in the bottom there, because we know that we never want to try to divide anything by 0. So we don't want the bottom, the f of x part, to ever be equal to 0. Therefore, in order to find the x values that we want to exclude from the domain, we are going to take f of x and set it equal to 0 to purposely see what x values would force it to be 0, would make it 0. And then we'll use those as our domain restrictions. So I'm going to look at f of x, which is just simply 9 times x. Now I'll take 9x and set it equal to 0. 9x equals 0. when I'm asking myself the question, when would 9x equal 0? Now, to solve, like our solving, we've learned, how to solve using inverse operations before. And so if you're going to solve for x, what you're doing is you're saying, find the x value or values that will make this statement true. Okay, that's what it means to solve an equation. So that's why we set it equal to 0, because we want to know what values of x will make this 9x equal 0. And then to solve for x, we're going to get x by itself. So instead of doing 9 times x, we want to undo that with the inverse operation, which is to divide. And if I do the same thing on both sides of the equal sign, everything stays equal and balanced. So 9 divided by 9 would give me 1. 1 times x gives me x. 0 divided by 9 is 0. And therefore, I do not want x to ever be 0, because I do not want the function 9x to ever be 0, because I don't want to divide by 0, because dividing by 0 makes the function undefined, makes an undefined number. And you'll even find that if you try to do, like, say 3 divided by 0 in your calculator, it's going to give you an error. In fact, it might say something like domain error to let you know you're trying to do something that doesn't make sense. All right, well, that's another problem down. See you in the next one.